Welcome to today's tutorial, and in our tutorial today we are going to look at a graphs of polynomials, and the question reads: the variables x and y are connected by the equation y is equal to x minus a 3 there, which is in the brackets. Again, we have got x minus 5 in the bracket. Then again, we have got x plus 2 in the bracket. So the question says some corresponding values of x and y are shown in the table below, meaning when x is -2, y will be 0. When x is -1, y will be 24. When x is 0, y will be 30. When x is 1, y will be 24. When x is 2, y will be 12. When x is 3, y will be 0. When x is 4, y will be -6. When x is 5, y will be 0. And when x is 6, y will be k. So the question says, calculate the value of k. So k is on the y-axis, and where k is, the value of x is equal to 6. So we'll have to substitute. Where there is x, we're going to put a 6 so that we can find the value of k. So therefore, we shall be able to write this equation as k being equal to x minus 3, then x minus 5, then x plus 2 there, where x is equal to 6. So that will be k is equal to, open bracket, 6 minus 3, you close. Again, 6 minus 5 there, you close. Then 6 plus 2 there, you close the bracket. So k will be equal to 6 minus 3, your answer will be 3. Then 6 minus 5, your answer will be 1. Then 6 plus 2 there, the answer will be 8. So when you multiply 3 multiplied by 1, then multiplied by 8, our answer there will be 24, and that is the value of k. Okay, we continue as we look at the Roman numeral 2. Now the question says, using a scale of 2 centimeters to represent 1 unit on the x-axis, for -2 is less than or equal to x, well, x is less than or equal to 6. So they are telling us that the x-axis should come from -2 to 6 there. Okay, and the scale of 2 centimeters to represent 10 units on the y-axis, for -10 is less than or equal to y, and y is less than or equal to 40. Draw the graph of y is equal to, open bracket, x minus 3, then close bracket. Again, you open the bracket, x minus 5, you close the brackets. Then open bracket, x plus 2, then close brackets. So how do we draw that line? Remember, if these lines here, they are representing a 2 centimeter, means that if here it is 0, here it will be 1, there it will be 2, there it will be 3. That is for the x-axis. Then for the y, if this is 0, that will be 10, and that will be 20, and so on. So that's how we're going to write these units on our x or y plane. Now, after we do that, we are supposed to know what each small box represents before we can start plotting. Okay, so our graph is going to look like this. Okay, on the y-axis, negative 10, 0, 10, 20, 30, and 40. On the x-axis, negative 2, negative 1, 0, 1, 2, 3, 4, 5, and 6. Okay, so before we can plot, we're supposed to know what each small box represents on both axes, the x-axis and also the y-axis. So we'll start with the x-axis first of all. Okay, so we'd say unit per small square box is equal to unit divide the number of small square boxes. Okay, so if you look at this one for the x-axis, you are told that this 2 centimeters is representing 1 unit, and there are 10 small boxes. So that means that it will be 1 divided by 10, which is going to be 0.1. That is telling us that one small square box on the x-axis is representing 0.1. Okay, we'll do the same on the y-axis. We are going to say unit per small square box is equal to unit divide the number of small square boxes. Okay, so here the unit that we have is 10. The number of small square boxes also is 10. That means per small square box it is 1. So as you'll be plotting, you know that on the y-axis, one small square box it is 1. On the x-axis, one small square box is 0.1. Okay, so we'll start plotting. Okay, our coordinates. The first coordinate, it is negative 2, 0. So negative 2, 0, it is somewhere here where I've put a cross which is in blue. Then negative 1, 24. So negative 1, 24. When you get to 20, you start counting, because one small box is equal to 1. So 20, 21, 22, 23, 24, it is there. So the point will be here. Okay, next one, it is 0, 30. 0, 30, it is here. The next one, 1, 24, we'll do the same. This is 1 here, we get to 20, 21, 22, 23, 24. The coordinate, it's going to be here. Okay, we continue. The next one, it is 2, 12. Where is 12? When you go to 10, you count 2 small boxes. It's going to be here. Okay, the next one is 3, 0. 3, 0, it is here. Then the next one, it is 4, -6. Okay, when you get to 0, you count 6 more boxes down there. 1, 2, 3, 4, 5, 6. Okay, it will be here. Next one, 5, 0, it is here. Then the last one, it is 6, 24. 1, 2, 3, 4, it will be there. Okay, now that you are done with the plotting, you are supposed to join them with a smooth, okay, curve, and that's supposed to be are drawn using your free hand. You don't use a rule. So you join these coordinates. Okay. Join these coordinates with a free hand. A free hand like that. Okay, so once you are done with that, you even label your curve as y is equal to, open bracket, x minus 3, close, you open again, x minus 5, close, you open again, x plus what? X plus 2. Okay, you have drawn the graph for our equation. We continue. Okay, the question further says use your graph to estimate the gradient of the curve at a point negative 1, -1, 24. Now, how do we find the gradient there? Okay, we are supposed to draw a tangent. Okay, we're supposed to draw a tangent. So let's look at that one. Okay, a gradient. Okay, so step number 1, supposed to draw the tangent, okay, to the what? To the curve. Okay, then step number 2, you pick 2 coordinates. 2 coordinates, okay, in the tangent drawn. Okay, and step number 3, then find the gradient, okay, using the formula. Okay, change in y over change in x. Okay, so we shall follow these steps. So let us draw our tangent at the point where x is equals to -1 and y is equals to 24, which is this one here. Now, we will draw a tangent, and that tangent is supposed to pass through this curve here. It's not supposed to touch the curve at 2 points. It's just 1 point. Okay, so, and where exactly? At the same point. Okay, here. So this tangent that we have drawn is touching the curve at 1 point. So that is step number 1. Step number 2, we are supposed to pick 2 coordinates. 2 coordinates along this tangent that we have drawn. Okay, 2 coordinates. So coordinate number 1, I would say this one here, which is negative 1, comma 24, where we have put the tangent. Okay, then coordinate number 2, it will be 0, 38. Okay, that's the coordinate there. Then you're going to label them as x1 and y1, then x2 and y2. Okay, once we are done with that, we'll substitute these values on the formula for gradient. Okay, so the coordinates that we picked, it's negative 1, 24, and 0, 38. Okay, so we've got x1, y1, x2, y2 there. So we shall say gradient is equals to our y2, that is 38, minus our y1, that is 24, minus 0, minus negative 1. Okay, so 38 minus 24, that's going to give us a 14 over 0 minus negative 1, that is 1, and our gradient there will be equal to what? Equal to 14. Okay, we continue. We will look at the last question. Area bounded by the curve where x is equals to negative 1, x is equals to 2, and y is equals to 0. Now, x being equal to negative 1, okay, it is here. X being equal to negative 1, and x being equal to 2, it is here, and y also being equal to 0. Y is equal to 0 in the x-axis. So the part that we are looking for, the area that we are looking for, it is this one here. Okay, now if you look at that one very well, you discover that we can demarcate that into three shapes, okay, which would be trapeziums. So if you look at the first one, which we're going to label as A1, the other one will label it as A2, the other one will label it as A3 there. Okay, or trapezium A1, trapezium A2, trapezium A3. Okay, how can we find the area of this part here? So from where x is equals to negative 1 to where we are meeting the curve, okay, at that point, okay, our to be the value of a, and the value of a for that A1 is equal to 24. Okay, it becomes a challenge for you to count. You can look at the table where there are coordinates. You discover that negative 1 is corresponding with the y value, which is 24. Okay, then where there's a 0 there, up to where we're meeting the curve, meaning x being equal to 0, where we're meeting the curve, y there is a 30. So the b there will be a 30. Okay, then where x is 1, where the value of x there, so the value of y there, which will be our a, for A2, it will be 24 also. And that one becomes the b value for A3. Okay, becomes a b value for A3. Then A3, the value for A there, it's going to be 12. Because where 2 is, the value of y is 12. So meaning from the x-axis to the curve there, it is equal to 12 units. So as you can see there on A1, the height is 1, meaning from 0 to -1. A2, the height will also be equal to 1, meaning from 0 to 1. Then at A3, the height will also be equal to 1, from 1 to 2. Okay, so after we do that now, we can write the area for that, and the area for that, and the area for that. Then we add them in order for us to get the area which is bounded by the curve, where x is equals to -1, and where x is equals to 2, and where y is equals to 0. So we continue even as we look at the answer for the last part. So there we shall say that area here, area, okay, bounded by the curve, okay, so that one is equal to area 1 plus area 2, then plus area for 3 there. So for 1, we shall say it is half, okay, a plus b, then height. Again for 2 there, it will be the same. Then for 3, it will be the same formula, because all of them there, they're trapeziums. So how do we find that? We'll now say, okay, half, our A on A1 was 24, our B on A1 was 30, then our height was 1. Okay, on A2, our A was also 24 there, then our B was also 30, then our height was 1. Then on A3, our A there, it was 12, then our B was 24, okay, multiplied by 1. You can just have a look at them again before we continue. Okay, our A there, A1, A was 24, then the B was a 30, this one here, then our height was 1. On A2, our B was 30, then our A was 24, our height was 1. On A3, the longest one is a B, it was 24, then our A was 12, and our height was what? Was also a 1. So we continue. So here we're going to say 1 over 2 multiplied by 24 plus 30. That's going to give us a 54 multiplied by 1. Then 1 over 2 multiplied by 24 plus 30 is going to give us a 54 multiplied by 1. Plus again 1 over 2 multiplied by 36 multiplied by 1. So the area for A1, it will be 1 over 2 multiplied by 54 multiplied by 1. That's going to be 27, okay, 27 units squared, plus 1 over 2 multiplied by 54 multiplied by 1 still be 27 units squared, plus 1 over 2 multiplied by 36 multiplied by 1. We're also going to have 18 there units squared. So if you add all these things, we're going to say area bounded by the curve is equal to 72, okay, units squared, okay, as the area for the last part. Okay, we have come to the end of our lesson today. We'll be able to meet next time as we'll be looking at another question. Bye bye and see you next time.